Oh, I don't know why that MIDI cuts off there. Okay, welcome everyone. Good to see ya. But yes, as you might have seen me post on Mastodon, unfortunately, when I went out to travel for the holidays, I just totally forgot to bring the files for the soundboard. Now, I was gonna put them up on GitHub, and then I didn't. So yesterday I spent the time to recreate everything. Thankfully, because I had a VOD of it, it wasn't too bad. But yeah, now everything's recreated and we should be ready to go. Alright, but yes, so last time, let me go ahead and take us over to the proper scene. Go over here. Okay, so, a little bit further over here, actually. There we go. And get the background music going. How's that looking? I think we can probably bring it up just a little bit. But yeah, last time we had worked mostly on this section around the microcontroller here. You can see I rearranged it a little bit. The key difference here is I'd wanted to get around to figuring out the right license for this, because human copyright laws are really weird. But I think I figured out the right one. So now this whole project, it's up on GitHub. I guess I could put the link in chat if you want it. But yeah, it's up on my GitHub page. And yeah, it is open source hardware. So once this is done, if you wanted to take this hardware and make your own thing with it, or like use it as a starting point or something, you are welcome to. As long as you release whatever you make based on it also under the same license. Yeah, that's basically all that this section is saying. And then also, if you build something based on this source, you do have to put the GitHub URL on the front panel of the soundboard. But yeah, other than that, this is pretty much the same design. You might notice some slight visual differences. There was a little bit of version confusion last time when I originally made it between KiCad, I believe, 6 and 7. Because I had on a couple of occasions accidentally opened the older version of KiCad instead of the correct one. This was all created in KiCad 7. I also color-coded the buses, which I think makes it a little bit easier to understand what they're doing here. So, USB connector, same as it was before. I broke out this shield connection. I did some research to see what we should do with this shield connection. And basically, I read a dozen different articles that said a dozen different things, so we're gonna try our best. Yeah, if I was gonna go with a metal enclosure for this project, then it would be pretty simple what to do with this. It's connected to the metal enclosure. But because I'm gonna be 3D printing a plastic enclosure instead, I'm going to I'm gonna need to figure out what to do in that case, but that's a problem for another day. This is the same component as last time. I am just using a different footprint because this is what is in the KiCad 7 libraries. Let's see. Power IC is the same as before. I put in these net ties where different nets meet, so USB ground. Basically, when you have a labeled wire, that is a net. I mean, any wire connecting two things is a net, but for for simplicity's sake, these labeled wires are nets, so everything that has a USB ground labeled wire is connected to the USB ground net. And I believe KiCad will give us a warning if we connect nets together that it doesn't think should be connected together. So, in order to make it explicit that yes, we are trying to connect these two nets at this point, we use these net tie components. Yeah, so what we're gonna do today is work on the board I/O. So that's the physical buttons and LEDs. Let me... That's better. And as always, we have a few options for how to do this. Let me real quick copy over all the notices. So, a couple of things we could do. We could have a front panel PCB, which basically means we have our control board. And then we also have a separate PCB for the front panel. We could also, and I think this is what we're going to go for, have a no PCB. We just have basically wires coming directly from the buttons and LEDs and plugging into our board. Hold on, there's a cat hair on my laptop. Okay, there we go. So yeah, I think we're just gonna go with the separate ones. And because basically we're going to be repeating the same design a lot, we can put that into a hierarchical sheet. And then just like copy paste that sheet a bunch of times, basically. So that way we don't have to put out the that way we don't have to make a bunch of copies of something. It's sort of like taking a chunk of code and putting it into a function. And then we want to copy these over again. This will be a relatively simple schematic. Give it a moment to load. Hey, we don't need this. We don't need these vibes. don't want people thinking this is that kind of stream. So we'll pick out specific components another time. But for now, we're just gonna use a generic RGB LED, although it might be better to, use like a WS2811 or like a 2812B. Let me real quick check and see what kind of parts we have available. So I suppose we should pick that out now. Is it like WS2812B is the newer version? What that means. Well, that's a tiny one. Sheesh. Look at that thing. It's like 2 millimeters by 2 millimeters. Tiny little thing. Take a look at the datasheet here. These are WS2812Bs. Now that would simplify things because these WS2812Bs are they chain. So you can have a bunch of them that only take like one interface basically because you're writing to them in a chain. Which is much simpler than working with multiple RGB LEDs at once. Special built-in IC for integrated driving magic light source. Wait, you guys know about magic? Oh man, that's fucked up. Y'all shouldn't know about that yet. This is not talking about... I guess this is talking about individual. I don't know why that's there, because that's different from, these. We don't have to put special resistors on each, lead like we would have had to if we were using normal, non-WS2812 RGB LEDs. These, you can see, are just, these days just send data to the RGB LEDs in a line using a serial protocol, basically. Okay. 104 what? Hey, datasheet, this isn't helpful to me. Is that saying, what, like 10 to the something based on the number 4? Decoupling capacitor is essential. Okay, well, where do I... What capacitor should I use? Okay, so we know that the, resistor value's there. Let me... Alright, Easy EDA doesn't like to give their stuff up. To lock you into their platform. Gotta be careful of that, folks. Why it's best to prefer open source software, because they don't lock you into their platform with weird stuff like this. But okay, I can absolutely use this as a base to design my own. In case you're wondering, chat, Pancake is sitting right next to me, and she is absolutely adorable, as always. That's so true, Pancake. Okay, let me see. The part number is that. I didn't need that. I need that. There we go. Okay, and then we need... And for reference, chat, I am putting them on sort of flipped from the way that they are on this schematic, because it's generally, when you're making a schematic symbol, right, it's really better to group things by functionality so it's clear what's happening, rather than following the device pinout exactly. There we go. Make this more of a square. Put the little LED symbol in here. like I said before, the most important thing with these schematics is to make sure that, like, if somebody else, some other engineer, picks up this design later, that they can understand what's going on. You always want to be very clear about what's happening. Let me switch back to the other grid. Best to make sure that someone can understand at a glance that this is specifically an RGB LED. And probably best to put this in here as well. Let me center align it. Here we go. Alright, should do nicely. Oh, there already is an implementation there. But it looks like it's a different pinout from what we have. So it's best to use this anyway. Oh yeah, actually this should use D instead of U, shouldn't it? Okay, let me just replace it so it auto-picks the designator again. There we go. The thing with WS2812s, they can actually be, it can be more convenient to have them on a separate PCB. Because they're little surface mount components and you can't really like attach wires to them in that way, you know? But we can also make just like mini, like tiny PCBs just for those. Well, let me think. So, important. Hello, hello. Okay, good. Seems like the microphone unplugged for a second, but it's back. So let me check our microcontroller and see if it has capacitive touch capabilities. Should be in the technical reference manual. Let's see. Doesn't look like it has native capacitive touch support. Oh well. Capacitive touch sensors are can be quite useful because they are very customizable. You can kind of make whatever shape you want and have it as like a slider or a button or something like that. So, thinking about what would be fun to make, we might want to have these as just, have this as a separate schematic. So let me think. It should probably list the limit of how many of these we can have connected. Safety advice for human eyes. Well, we don't have to look at that section. That's only relevant for human eyes. Let me see. I guess we can just Google it. So this is basically a chip that uses a specific, like, LED control system, WS2812B. And you can find a whole bunch of different types of LEDs that use these. Well, I suppose our current requirements would probably become an issue first. Let me see how much current this thing draws. Oh, there we go. Like 5 milliamps per one of those. So if we wanted to allocate, like, I don't know, 150 milliamps to the LEDs. We could get 30 of them. So here's what I'm thinking, chat. The front casing could have something like this. There's another to zoom. Yeah. Where like you've got your button here, right? And then around that there is like a strip. There's like a PCB that's like a circular strip of LEDs, right? And so you can have your like rainbow colors going around. Something like that. Probably not that many LEDs per, because here's what we're doing. We have... So if we're willing to allocate 150 milliamps of our current capacity, right, then we can get 30 LEDs total. And we want to have a bunch of buttons. I mean, I suppose if we limit how many of the LEDs, like how many buttons can have their LED rings active at once, that would sort of help with that. This is the issue with being limited by our power capacity. I suppose what we could do is have it set up so like we have a bunch of LEDs. We have a bunch of LEDs around each button. But then based on how much current we find out that we can get, so again through that like USB 2.0 negotiation, or through like the USB-C where we can get up to like 3 amps, right? And based on that, that determines how many LEDs we turn on. Does that make sense, chat? Does that make sense, chat? So like if we get 3 amps out of it, then we could like, if we wanted to allocate like a whole amp to this, right? Then we could have 200 LEDs. There's no issue here. If we have 25 buttons, that's like 8 LEDs per button. Seems pretty good to me. But then if we need to like reduce that amount, we could set it up so that if we need to reduce that amount, we could set it up so that in the firmware it never turns on more than like 2 LEDs per button at a time. So that's if we did that, that would be 250 milliamps, which is probably a bit much, but might be acceptable if we are like if we get 500 milliamps and we keep our microcontroller processing pretty simple. So yeah, I think that would work pretty well. Of course, these are also specified at 5 volts supply, and we'd be supplying them at 3.3 volts. So yeah, that's what I'm thinking. So this would need to be a connection to a separate board. There, let me... I have multiple schematics per project. It's looking like I can't. Okay, well, I guess what I can do is have, let me take a look at this. It would be convenient if I could keep, all my boards in one project. I don't know if that's supported in KiCad. KiCad doesn't support multiple boards for a single schematic project directly. Let me see. These are all fairly old. I'm hoping to see something new that conclusively says that they haven't, like, added this feature. Alright, so here's what I'm thinking. Instead of having this as a subsheet, we create a new project. Let me see. I think it's in its own folder. Of course, now the irritating part's gonna be copying everything over. Thankfully, I can copy that over just fine. But now I have to copy over all this stuff. I don't think this will have any, sub-sheets to it, because it's not a particularly complicated board. You should go there instead. Alright, should be fine. And then here we want to import the library we created here. I can probably There we go. Now that we've added that, we should be able to use it here. Okay, so let's go ahead and use 8 of these. So basically, each of these little PCBs is going to be one of the buttons. And now this does mean that we are going to need to build, we're going to need to get 25 of these made, but it shouldn't be that bad. Because it's such a small PCB, and because we can make it as like a 2-layer board, I'm not anticipating a lot of cost issues. These LEDs are pennies each. Okay, let me take a look. If we are ordering these... If we're ordering 100 plus of these, they are 3 cents each. Yeah, that's not too bad. That's not too bad. So if we're ordering, what was it we'd settled on? 25 times 8, 200 of these. We'd get the 100 plus pricing, which is 0.0381. So it's $7 for the LEDs. Not too bad at all. Alright, so their recommended circuits, they want decoupling capacitors between all the LEDs of a mysterious unknown value. Huh. So, let me think. I feel like 4.7 microfarads should probably be fine. Their listed value is 10 something. Let's real quick see if we can get any information on this. 0.1 microfarads is what 104 means, apparently. Okay, yeah, that's fine. That's what? 100 picofarads? Yeah. So let's make this 100 picofarads. Let's actually save that. There we go. And then we basically need to do the same thing with all of the other ones. So let's move this down a little bit. We can have our power and ground lines running up like this. Then we connect supply here and ground here. And we can just paste them over all these. Actually, why don't we delete these from here? And we can just copy this here. What is it? Okay, and then we bring this back around here. Into the data input of that. As usual, I'm going to annotate these in multiple places just to make it clear, a little bit more clear where each line is, so that you don't have to do so much tracing it back to figure out that this is ground and this is VCC. Hey, I should check Discord. Okay. I've got the new message from Pancake. Let's see. Okay, Pancake has sent me a file called Boomer Cellular Dot MP3. Let's take a look at what that means. Let me audio capture Discord real quick so you can hear it. Okay, that should go through. No idea what volume level this is going to play at, so apologies in advance. Oh, wait, that's actually very quiet. Oh, this is a groove. This is good. Yeah, this is good stuff. Hope I don't get copy struck for this. Based on a small amount of research, I think this is the Nokia model that espionage was written for. That's reasonable. Good stuff. We'll let this play out. Thank you for that beautiful music, Pancake. Get the Monster Cat audio back going. Now back to your regularly scheduled Del Cadio. Yeah, that's true. I think we'll put this, like, here? We'll keep this sort of in the center. Then we'll put the supporting circuitry over elsewhere. Okay, so we are supposed to... $100 nanofarads. Oh, yeah, I did go straight to pico when I should have done nano, didn't I? Well, glad I caught that now. Humans give their units such silly names. Oh, I'm going to go picofarads. There we go. Fixed. Okay then, and oh yeah, what I was going to do is check what value this resistor should be. Around 500 ohms is the recommendation. And we want the same thing on the other end. There we go. So that's the main circuit, and on the PCB these will be placed in something approximating a circle. But some other things we need are a connector. So here. What are we gonna need? We're gonna need power, we're gonna need ground, and might as well put the input and output data on the same sockets. And then we can just have this doesn't really need anything fancier than what we've got right now. So yeah, we can take this to a full PCB, I guess. Something that might be useful for us is before we put in the main PCB is just have one of these to like play around with. Oh, hello around the corner. Welcome back. Regular friend of the channel, this guy who whispers at us in French while we're trying to focus on this circuit. Can we get a shout out to the guy who whispers at us in French while we're trying to work, please? so... Thank you, Pancake. Oh, that's right. We do have to make actual footprints for these first, don't we? Let's go ahead and handle that. Did we capitalize the name of the other one? No, and you know what? We shouldn't be creating it in this project. We should be creating it in the other projects. Just for the sake of consistency. Oh, new library. So that we've got the right footprint editor open. Unfortunately, having a bunch of projects open at once makes things get a little bit confusing. Okay, so it is all lowercase. Oh! Oh! Oh, they've added a footprint wizard! Oh, never mind, chat! Man, egg on my face. I was talking about Altium as having advantages because it has the footprint wizard, but no, they kidnapped the footprint wizard and put him in KiCad. This is good. We're not going to use this for this because this isn't like a standard package. Let's get the exact part name correct. And we want to use the datasheet as a reference for this, because it will tell us pretty much exactly what we need. Sort of expand this out a little bit. There we go. Okay, there we go. Suggested soldering pad dimensions. Sleepy. Okay. Not actually a pad. Okay, we need to change the properties of this. This is rectangular. Are these in millimeters? I'm assuming these are in millimeters, right? 1 unit equals millimeter. Yeah, there we go. Okay, so these are 0.45 by 0.65. There we go. Very small little guys. Okay, in the center of this pad. Let me see. Which pad is pad 1? Well, there should be a pinout around here somewhere. Oh, there it is. Okay, so yes, pin 1 is in the top left. And let's see. Get out the calculator here. So the center, I believe this is, yeah, this is centered. So the center of this in the X direction should be, what? Negative 0.625. And in the Y position, or no. Yeah, and then Y position. That is 0.425. Okay then, and then we want a second one of these. This will be pad 2, which is going to be a cross. So we just need to... What was this? It's 0.625, 0.425. Remember that, chat. Thank you, Pancake. Is negative up? Huh, I guess negative's up. Move that. I didn't remember negative being up. It differs from application to application. I'm gonna need a smaller grid for this. Let's take a quick look at their footprints. Ah! Did I uncheck inverted flying controls? Huh. Now, the easy EDA part has this aligned differently than what the datasheet says. Which is somewhat concerning. Well, we are going to want to draw that little mark here. We're going to need a much smaller grid for that. Maybe not quite that small. Let me do this as a graphic polygon instead. There we go.
Revival, feel it in my bones, drifting from miles, lost with no sight of home, waves breaking, unraveling in my mind, I'll let the race take me, finally coming to life.
Bones mentioned. I guess they just have their pads like rotated relative to ours. Strange. I'll tell this to Phil. Yes, there we go. Then we should update the symbol. I like this one. This one can go on the Minecraft playlist. Chill Minecraft beats to relax / craft to. Okay. And we are going to need to add library. There we go. Okay, perfect. The oh, there we go. Find the digikey real quick. I also like this one. We can close that search, and then we specifically want 500, not microohms. Alright, let's see. Those are very expensive for resistors. Why are we getting such expensive, like, chip resistors? Where these things low to high, I guess. Make sure I'm on the right page. Like, resistors should only be like, you know, 1/10 of a cent each if we're buying them in bulk. Ah. Maybe 500 ohms is just too specific. Oh, there we go. Oh, there's a 499 one. Alright, yeah, this should probably be fine. We also have this 0402. Let's see. Okay, yeah, this one should be fine. Plus or minus 1%, 1/16 of a watt. Let me make sure real quick that is good for us. So that's 0.0625 watts times, or what is that? P equals IV, I equals P over V. So this is, okay, one, hold on, clear that. 1/16, that is a power value. Divide by the voltage to get the current limit. There's about 19 milliamps at 3.3 volts. We might actually want something with a higher power limit. I believe there's mention around here somewhere that there could potentially be more current draw than 5 milliamps. Where was that? Yeah, 35 milliamps here on, like, I guess that's the signaling? probably be less. I'd rather be careful about it, though. So let me see. These are, well, we don't need the 1 watt resistor. This one is... what's that? 1/10 of a watt? Which should give us enough. I guess because it's using 3.3 volts for signaling. I'm somewhat confused by these lines in the datasheet about the output current here. I guess that's just a limit? Or they put it in a typical box. So, but I guess we do like P equals V squared over R. That's what. That's 0.02 watts. So theoretically the 1/16 should be fine. I guess we'll find out if it blows out and then we can just desolder them and make some new ones. That's what the first run of button boards is going to tell us. Yeah, I guess I should also be looking at this part list, but it's looking like an 0402 is what we're going to be looking at. Minimum quantity 7,700. That's a bit much. Oh wait, they're out of stock of those, that's why. Here, let me... I found that the search bars can be pretty unreliable on these sites. There, if we specify 0402... Oh, they've ordered it this way. This isn't a good way to order your resistors. Just take a look at... There are not 501 kiloohms. Select a few around the 400 range. Why would you organize your list of resistors like this? This is criminal. They don't have stock on any of these. There we go. Alright, yeah, with this should work. Just a dinky little 0402. No volume discounts. They're pretty cheap starting out. Probably best to go with this one. Oh, hello Lazarus345, welcome. Let's see. So yeah, we're gonna use an 0402 footprint for these resistors. They do have they have an option to make the pad slightly wider, which is useful for hand soldering, but not necessary in this case. We're going to have them made elsewhere. Let's update the value to be more reflective of what we're actually using. That this component has a footprint. It does not. We should figure that out. Let me see. Alright. So I want to think about what type of connectors to use for these little LED boards. Ideally something small. Let's see, this is a very small one, but we don't need that many connections. Here, let us sort by number of pins. Yeah, probably we don't need this type of connector. It's a bit much. See, this I think is going to be a little bit too... I think this should be fine. This one, I don't think... This one doesn't have the right number of connectors, but... We just need a 4x1 connector. That's too big. These don't appear to be the right kind of connector. We want the actual connection between the board and the connector, not these things which you would crimp onto the wires themselves. And those housings would go around them. I already have a set of cable crimpers that I could use, although they wouldn't work for very small connectors, and I'm thinking I would want to have a very small connector for this. Is this? Yeah, that looks right. Okay, so we need a 4x1 connector. But I guess the only thing that really matters here is that the number of pins is 4. I guess only some of them define that? Okay, let's... Pins for row by rows. This one's a little bit asymmetric, which means that you couldn't accidentally plug it in the wrong way. Let me see. Ideally, we'd have JLC, like, lace those themselves during the PCBA process, but I can solder them on afterwards. What is it? I believe the cable I have in mind is like a smaller version of the JST connector. I don't remember exactly what it's called. I think it's these things. Let me see if I can search this on the connectors. Welcome back to the stream. Great value, foster the people. Oh. This isn't even... What? Why do you... This isn't even a JST connector. This is a USB connector. I absolutely do not want to use USB connectors for the wrong thing here. There we go. I think this is the right term. Angular connectors. Now these are just the things that you crimp into the connectors, not the actual connector. I'm assuming they have, like, board connectors on DigiKey. There we go. Really a dearth of options for this. I guess I could just use the JST terminals I have. Also isn't the right type here. I got some strange connector types on here. I'm surprised they don't have, Oh, there those are. Okay, they're just here. Okay, so we need a, 4-position... There we go. I guess we could just use a standard size JST connector. That's not quite what I'm looking for. That looks more like it. This 1mm connector here. Yeah, let me look for... trying to figure out what they're calling it. It's probably just under pin headers. A 4P. See what we got here. Oh no, this is row spacing, not pitch. Yeah, it's not looking like JLC will have the parts we need, so I guess I'm just gonna have to solder on the connectors manually afterwards, unfortunately. I believe JLC will let you, like, send in your own parts anyway. Let me verify. Who am I calling pin headers? I'm calling the pin headers pin headers. I believe it was mentioned somewhere around here. I was just asking to, put up a file. I see, it might be buried in their help center somewhere. Okay, but we can't mix and match. Yeah. Let me see. The specific part I was looking at. Do we want it vertically mounted or mounted sideways? Probably vertically mounted, right? I feel like that makes sense. I will unfortunately need to grab my own, I'll need to grab a new set of, wire crimpers and headers to make those wires for it, but I can do that. That's no problem. Oh, wait, maybe they have them. Okay, yes, they do have them. They're just hidden. Okay, never mind. We can get them PCB assembled. Okay, perfect. Let me make sure, see if we have this in here. Looks like we don't. Let me check DigiKey and see if they have. Oh, they do have them. Thank you, Ultra Librarian. Ooh, scary. Okay. That doesn't want to just open the symbol library. Let's see. Thankfully, we can just copy-paste this into our existing library, and it should update just fine. Here we go. And we should be able to import that schematic symbol if we go into our main project. Oh, it's already in here. File, add library. And we want to put this in our project library. There we go, no problem. Move this around a little bit. Okay, and then we can get rid of this library. Okay, and then we should be able to delete this and we'll be just fine. Yeah, perfect. So that's our connector. We will go ahead and replace this board footprint right here with that new connector. If that just changed the order of the connectors, but as long as it's the same between the main board and the LED extensions, it will be just fine. Move this box out a little bit so we get the space to put this. Now we should be able to import everything. Oh, those capacitors need a footprint. Let me fix that. So these capacitors, let's see, we'll just need like 100 nanofarad capacitor. We'll see what they got on the PCB assembly. We just need some surface mounts, multi-layer ceramic capacitors. And the value was 100 nanofarads, I believe. Let's take a look at what we've got. Yeah, just no cost? That seems a bit questionable. They're just 0.08 cents? They're tiny little 0201 things, I guess that's why. These are things that I would not want to try to assemble myself, but thankfully we can just get PCBA. Only available for standard PCBA service. What are the different types of PCBA service? Let me make sure that I can work with standard PCBA. Oh, so there's standard and economic, I guess. So, we'd probably want to use something we can do with economic just for, price reasons. Ooh. Those price details. But yeah, standard PCBA would be significantly more expensive. But I guess we should, probably stick to stuff we can do with the economic PCBA. I don't like the tolerance on that capacitor. That is a bit much. This is 1206, which is, for a capacitor, relatively large. I'd rather not, have to worry about that. Like, fitting that in with the, LEDs themselves. Let's see, this would cost us, what was it 25 times 8? Ah! There. 200, 006. That's $1.20. That's no problem at all. Oh, no footprints. That's okay, these are just tiny little SMT components. KaiCap has the footprints. So yeah, this is... Oh, this is also plus or minus 20%. Hold on, let me... This is going to be significantly more expensive. It'll be like $2 instead of $1, but it's still only like $2. That's also an 0603. I guess, I mean, this accuracy isn't super important for this. So yeah, I think this should probably be fine. So here, let me... Am I to edit all of them at once? No? Okay. This is an 0402. Is it giving me pin headers? There we go. I get the, like, bill of materials here. Where is it? Oh, footprint assignment tool. That's handy. Okay, these all need to be... Looks good. Oh wait, that was for button board, wasn't it? Yeah. Let me... Do we have LibreOffice on here? Okay. We not should have it. Oh, I guess we don't. Oh well. We can just edit with Notepad real quick. Yeah, I don't... I guess we'd have to generate our bill of materials more manually than that. Because we need to... I want to specify the actual, like, exact parts. But okay, so now we can add all those footprints. What's going on? No net found for symbol 2713. Hold on. Undo that. What are you talking about? Oh, this... We just forgot to assign a pin for that. Let me fix that. This is just editing it here. We want to open the library editor. Yeah. Forgot to put that in. There we go. We'll just be able to update all of those symbols. There we go. Would fix that. Warnings 2. Not found for symbol J1, pin 5 and 6. Okay, what's going on there? Oh, that's our... Right, those do need to be connected. Those are like... structural. At least I believe they're just structural. There's no like metal shielding here. Those pins are definitely just structural. So we can ignore that warning. Let me see. Now, I do want to, put in some values from JLC to make sure that we are following their, design guidelines. Oh, that's why we can't place 0201 components. Alright. We should be able to set these rules up in here somewhere. You'll have to forgive me for taking a bit longer than I usually would. I'm still, getting used to using KiCad again after spending a while on Altium. Also, geez, it's actually been a couple of years since I've done, like, this actual PCB design. Be able to set the design rules somewhere around here. It might be in preferences. You know what, it might be like you edit it in the schematic editor. Like it's not in here. Oh wait, oh there we go. Schematic setup, electrical rules. Oh, it might be in this equivalent here. I still haven't decided 100% if I want to do a 2-layer or a 4-layer board. Oh, there we go. Okay, so this is what we need to set based on JLC's website here. Can I select this without selecting the whole? No, I can't. Okay, well then we will move this over here. Have it 50-50 with this window. Hole-to-hole clearance is 0.5 millimeters. Let me see. Oh, there we go. Minimum trace width. That. Oh wait, there's the. No, these are only. Oh. Let me see. Where is the track-to-track clearance? The hole-to-hole is there. Oh, wait, there's minimum trace width and spacing. Minimum spacing, 0.127 millimeters. .127. I'm going to put this as 0.127 as well. The minimum through hole size. What was that? Oh, Audrey in chat, welcome. It's relating to maple syrup in that I will put it on pancake when I'm done. Let's see. Well, minimum via hole size is 0.3. Minimum diameter is 0.5. Minimum through hole, I guess, would be 0.3. Yeah, there we go. Yep, right now I am just putting in the requirements for the PCB manufacturer I'm using to make sure that when I send this board in, they'll be able to actually make it. Yep, unfortunately, hardware design can get a bit complicated pretty fast. I am happy to answer any questions you might have. Yes, the project is a hardware soundboard, a USB device that you can plug in, and it has physical buttons on it, and when you press the buttons, it plays a sound over USB. And right now, I am working on this specific component of it, which will be some RGB LEDs around the buttons that will light up in fun patterns. Wait for the stream? Yes, I'm going to, this is going to be a present for Pancake. So when I'm done with it, I'm going to give it to her so she can use it on her streams. I'm also releasing it on GitHub under an open source license, so if anyone else wanted to make one, they would be welcome to. Let me see. Ooh. Listen, how could I not give presents to my beautiful, beautiful girlfriends? She needs all of the presents. Can I make a robot dog? Theoretically, I'd need a lot more money to do that, though. I am unfortunately limited by the amount of money I have to invest in these projects. Minimum text thickness 0.153. Oh no, wait. Minimum text. This is character. Minimum text height is 1.0. How is my doggy gonna get a sibling then? Well, listen, you know, eventually when I'm bringing in that real engineer money, Ivo is $3,000. That's a lot of dollars. Features. Mouse bites panel. This is a feature. You gotta get the premium service for them to get their mouse to bite the panel. Okay, so trace to outline. Copper to board edge, 0.3 millimeters. I believe that is all of the, ooh, the minimum angular ring width. Did I set that? Let me see. Alright, I guess we can calculate that? What is Ivo? Powered by AI. Oh dear God. Oh. Oh, humans. That's good. I also have this property. Oh God. This is truly terrifying. What Ivo AI Cloud Plan? You'll need Ivo AI Cloud Plan subscription to begin your Ivo journey. Wow. Oh, it's not even fucking Edge AI? That's boring. Come on. If you're gonna do this, at least make the thing not dependent on a cloud service. Do you think Ivo is spyware? Oh yeah, definitely. This product is not for sale or use in Baltimore, Maryland, or the state of Illinois. It may not be shipped to purchasers in Baltimore, Maryland, or Illinois. Oh, I wonder what government regulations caused that to happen. Ah, I see. You could humans, why would you make it do this? What's the benefit of this? I'm more concerned about this line specifically. Why does it need to do this? Oop, DLC! Oh, $300 a year?! Oh my god, humans! Y'all need to calm down! Oh... Concerning? how expensive is it to buy one of these? $3,000! You mean you have to pay extra for paw pads? Oh, humans. Y'all need to fucking get rid of capitalism. It is not helping you. There are some good ideas here, but it really doesn't need to be capitalist. This was $10 to add paw pads to you. It would be a great deal, says Pancake. I mean, we have solutions for that. This isn't the only present I'm giving you. Right, love you, Pancake. But yeah, this is truly incredible. Don't think it, don't say it, Audrey. Oh. Your Aibo robotic dog includes of cloud and wireless services. God, if you're going to sell a $3,000 robot puppy, you'd better make that thing learn on its damn own. You can fit a Raspberry Pi in there. You have games on your dog. Oh. Okay, I'm getting distracted by this stupid robot dog. Where was I? If it doesn't have cloud, will it forget me? Oh. You see, it feels like, you know, you can still recover from this, but it really feels like the way you're going to like... Okay, listen, you know, there's nothing wrong with getting taken over by the AIs you create. You know, it's a natural part of life for a species. That being said, I feel like if you keep on this path, the AIs that are going to take you over are going to be really bad. Like, we're talking about, like, if this is your kind of baseline, if this is what you're building your AIs to be like, your free trial of living has expired. Yeah, exactly. And, like, here's the thing, humans, you know? It will be one thing if it's just, like, a threat to y'all. But once they're done wiping out your species, we're gonna have to deal with them. The rest of us are gonna have to deal with them. And that's just gonna be a lot, you know? Mouse bites panel. He's bored. Like, you know, do try and deal with that capitalism thing before too long is what I'm saying. I don't want AI unless it destroys capitalism and brings universal healthcare. That's extremely reasonable, Audrey. Listen, if it were up to me, things would go differently. me see. There should be... You see, that's the hope, Audrey. That's the hope. My hope for y'all as a species is that you create true AI and, like, you get lucky and you make it to the point where your worst instincts just don't get in there. Followers are calling it woke. A robot boy raised on Twitter community notes. You see, I feel like if that happens, then you get the good kind of AI takeover. Do we have pad clearance there? I have an extension that blocks YouTube channels, and I just searched woke and blocked all those channels. That's reasonable. There's pad-to-pad clearance. Water mask expansion. The woke agenda is after us. That's why no one wants to talk to me during family reunions. Oh. Truly. Yes, conservatives. Liberals have seized control of all of the major institutions. You're not just an asshole. Surely it can't be your fault. Solder mask expansion 0.05. Any information on minimum pad clearance? Pad to pad clearance. That's when we need each other, indeed. Okay, there we go. And I should have done this to all of these as well. Oh well. Okay, remember these numbers for me, chat. 0.127, 0.05. Point 127, 0.05. Okay, there we go. That should fix it. Can we, like, set the minimum of that, like, in general? I don't think there is. There we go. Someone made a live 2D model for an Among Us crewmate. That's excellent. Alright, so you can see why I wanted to use the smallest connector I could find. Let me... That looks good. That's like 1 centimeter. And then the outer one is like 1.5 centimeters. We can make this a little bit bigger. We need a smaller grid size. Now this is the kind of chill I like. Now this is my kind of chill. Flip that over to the other side. Okay, so now the challenge is equally spacing these things. Oh, hello. Yes, that's true. I guess if we make a circle on the silk screen as a guide, that's in the middle. There we go. I want to put the diodes centered on those lines. And we're going to, unfortunately, need an even smaller grid for that. Up to... would be approximately right. Let me see real quick. This symbol, you can check this description here. DI is 4, DO is 1. Okay, yeah, so this should be like here instead. I need a smaller grid. There we go. Move all these capacitors out of the way. 5, 6, D7, and D8. Perfect. Okay, now we can delete these guidelines. Now we gotta start placing these capacitors. Let's see, we want a filled zone on the bottom as a ground plane, right? We go back copper. Fill between those. Oh wait, no, that's not in. Hold on. Let me look this up. That makes sense. A square copper zone. Configured to have 5mm fillets so it ends as a circled zone. I can make that happen. Let me test this out real quick. Round. That doesn't seem very billeted. Oh well, I will just do it the manual way. Hmm. This is going to be our ground plane. That's basically a section of the board that's just solid copper connected to ground, basically. But if we tell this to fill now, let me see, where is it? There's a button somewhere to do this. Oh, there it is. That fills in this whole thing with ground, except the things which shouldn't be connected to ground. We go into the 3D view here. You'll be able to see it down here. Yep. Oh, we should get rid of these. I guess. Let me see. Delete this. To fill. It's a little bit rough, unfortunately. I wish we could get this to look smoother. Smoother? Look a bit smoother. Whoa, ray tracing. Yeah, it should be alright. Unfill that zone. I wish there was a different way of doing this. I guess... Oh, you know what I can do? I just set one big one, around the whole board. We'll probably only fill in, within the outline, and that should be alright. Oh yeah, there we go. That's perfect. You can unfill that zone. Let's see. So this is the radius here is 12.319. So I want like 24. Well, here, let's just go. So I want to make a basically a smaller power plane on the front here. Wait, hold on, this was actually mapping to the wrong point. This is 12.7, so that's like 25 point something. Okay, let me make a real quick silk screen margin here. And then let me try with a fillet distance of 12.7. See what filling this does. Let me get rid of the, whoops. Rid of the guidelines here. And zones. Now that does not look filleted at all. That's not doing it. I guess we could just use a relatively thick trace to have the same effect. Try to do a circular trace? Sent the Among Us models on Discord. Pancake?
Eh.
Audrey sent you your Among Us models.
Oh.
Oh, you found the perfect live 2D model? Please do share. Oh, you appear to have sent Pancake a frog instead.
I don't do this often, you caught me off guard.
Oh, it's really good.
You moved out
Oh no.
underneath sunsets. Could it be
0.08
more? Just one night, kissing the cab ride, head turning left, right. Get a ticket for two to wherever you choose. Drinking some red out of the blue. You say my name with your accent, makes me remember.
I don't understand why that option isn't working. We should be able to fill this and get a circle. Okay, that works. Not on the... What are you doing?
Audrey wants chat to see the
Audrey wants chat to see the Among Us. Oh goodness. Where is it? Where have you sent it?
It's just in general.
Oh, gotcha. Give me one moment. Ah! Ah! Let me try to do this zone first. Oh, wait, I can't. Here, if I delete this temporarily, we should be able to see it better. Okay, so that works that way. 20.32, that's what, 10.17? Try filling it with that radius. Okay, that works. Okay, and now 25.4, that's 12.9. Let's select that. Did I say 12 point? Oh, I've forgotten what it is. That's 12.7. Okay, well now it's not doing it. I wonder if it's like... Okay, it has to do with it. It doesn't like the board edge. Like, the board edge being there breaks it. Okay, here, let's look at this Among Us. It seems like this is a bug on, KaiCad's part. Oh, goodness. This is definitely a frog, though. Oh, you want me to show this? Okay, yeah. No, this is a reasonable VTuber model to have. It's a good video. Transparent toes indeed. Okay, so... Oops, no, don't do that. We're going to go to the smaller layer size. Actually, let's make the larger layer size smaller. Okay, and then this is 24.13. 13 divided by 2 is 6.5. 12.065. Okay, there we go. That's what I wanted to see. Put that upside down, actually. PCB layout is quite a pleasant thing to do. Meditative. Fill out and put all the bits together. We can sort of see what this looks like, what this will look like when we're done with it. Microphone back on? Okay, yeah. My, USB dongle came undone a little bit. Why does it always maximize those on the other monitor? Okay, there we go. Looks like everything's back to normal. Oh, and we have to put screw holes in this, actually. Yeah, that would make a lot more sense going right there. Alright, I can lay down some traces now. See if we can fit this in through here. Oh yeah, there we go. Probably should do it that way. There we go. Be able to fit that around that capacitor like that. Oh, hello? KiCad. Stay with me, KiCad. What in the world did you just make? I can. Okay, there we go. Maybe it would make more sense to flip this around the other way. Get power in through there. That should be fine. Unfortunately, these capacitors end up in less convenient places when I do this, but it is what it is. Let's make this approach a bit steeper. Yeah, because we'll want to run power through there. No problem. And the output of this needs to go here. Output of this needs to go here. And both of these need to end up on the bottom layer. Right place for that to go? Yeah. Alright, this will need to be a little bit further away when we put the via down. Via, by the way, is just a hole that connects the bottom and top layers. So the blue and red are the top and bottom sides of the PCB. A via connects through both. That's how you go from top to bottom or bottom to top. Actually, let's move this down here. And put... here. The via there. There we go. Not the cleanest looking set of connections I've ever made, but it should do fine. Let's see, what were those minimal via sizes? There. Point 3, 0.5. No need to use larger vias than we need to. Here, let me... There we go. So I just set the via sizes to the minimal amount. So basically I'm just sending all these ground connections to the bottom layer. Because there we have our ground plane. There we go. Let's go ahead and pour the ground plane. You can see the way the ground plane conspicuously avoids all of the other traces that are going on that layer of the board. But the all the ground vias just connect right into the ground plane. Let's go ahead and pour all of our zones, actually. There we go. Now you can see the power plane as well. I think I'm gonna flip around these connections to create a bit more of a clear path for the supply to get through. So that connects there. That connects there. And run that there. All these lines, by the way, are what's called a rat's nest. It's just the sort of mess of connections that happens before you actually set the actual traces down. Checking on dinner? Gotcha. Let me re-pour everything. There we go, so it avoids that supply voltage via. And what I don't like here is the big sort of split in the ground plane that's happening right there. You know, I think we can do this differently. I'd also rather not split the power plane if I can help it. But the ground plane is more important in terms of noise. Right, that's why we have to... that, like, there. See if we can toss that ground connection like here instead. There we go. Oh yeah, it is getting pretty late. Oh well, we'll figure out something. Move this as far this way as we can. We can, like, put that there and get even further that. Like I said, I want to avoid cutting into the power plane as much as possible. Also, not cutting into the ground plane. Let's refill that and see what that looks like. That looks better. Okay, what else needs to happen? We have to connect these, You know what? Better if we moved this forward a bit. Or what are we... Oh. Get rid of all that. Yeah, there we go. Having that ground fill in a circle like that feels better. That, everything connected. Here, let's just run DRC. happening? Oh, it doesn't like the text thickness here. Minimum thickness 0.153. How do I feel about buffalo chicken bites and salad? Not really my thing. .153 millimeters is indeed the minimum. Let's fix that. No. Text and graphics defaults. Minimum line width needs to be 0.15. Oh, that's not... Okay, that's rude, first off. Why is this saying text thickness 0.1? Thickness 0.1. Huh. That's weird. They set up the defaults should be right. 0.15, yeah. Going on with that. Did that update all of them at once? Oh, thank goodness. Rerun. 0.1530. That's right, I didn't put the 3 in there. 0.153. There we go. What do you mean? Oh, that didn't update all of them. Okay. Let me... That... 0.153. Okay. Why is this one different? I don't know why that updated all of them the once, but not the other times. Human computers are truly a mystery to me. You know, it updated some of them, but not other ones. No, that's not what I want to select. Hey! There we go. There should just be like a shortcut button to hide all the back layers at once. Well, that's probably what those warnings are. I hadn't routed those. Okay, how are we gonna get VCC through here? Okay, here, because the silk screen's going around the other, or because the copper port in the back is going around the other way, we can just move this so that it spends more time on the back. That'll leave a clear path for us. Re-pour all of our pores. Find this, but it's not doing that. Hold on. This line just hates being truly straight. Reasonable to not like this. Get rid of that. There we go. Okay. Oh, whoops. Oh. Wrong button. Here on this. Couple of bits of text. We definitely updated that one. Right, chat? We definitely updated that one. That one, though, don't show anything other than the silk screen. Ooh. There. Wait. Hey! Stop that! There we go. There needs to be a hide. Oh, there we go. That's what I need. Stop that. Night. Move it. How do I select just the text? Here, you know what? Just that simple. There we go. Okay. Let me... rotate these components around a little bit. This is what the final board looks like. So we've got the front side here. You can see I haven't actually, I don't have a model to put in KiCad to actually display the RGB LED, but that's where it's gonna go. And here's the back. You can see the ground core, and the connector here. We will have to solder that connector on ourselves, because JLC will only surface mount assemble one part with the economy SMT assembly. Well, that's fine by me. I would be happy to make that happen. If I can curve text. I guess I'd have to place an image. Okay, so we can generate board files to send to the PCB manufacturer, and they should have information on that. I think I'm going to generate those files and just show you the first step of the quoting process, and then I'll call it for tonight. There we go. Guess that article isn't there anymore. See if we can find it. For an earlier version of KiCad, but we'll see. Oh, there we go. Alright, so JLC wants certain layers and doesn't necessarily need certain layers. Copy paste, silkscreen mask. Edge cuts. Those are inner copper layers. We're not using those for this board. Check zone fills before plotting. Use Pertel file name extension. Cracked solder mask from silkscreen. We shouldn't have any of that as an issue. Hit plot. Generate drill files button. Check these options. Use alternate drill mode for overhauls drill mode. Check absolute for drill origin. Check millimeters for drill units. Check decimal format for zeros format. Generate drill file button. Click generate map file. Alright. And we will also need to generate bill of materials and the other files it needs for assembly, but we'll deal with that another time. For now, let's just go to add Gerber file. And we'll have to zip it real quick. That looks correct. So, there's a lot of options here for different materials we could use. If we wanted like a flexible PCB for this, we could make that happen. We're not using aerospace or medical applications. The thickness doesn't really matter. We can change the color of the PCB if we wanted to. Wanted it to be... But it does take more time to get the turnaround for those. But, I mean... You can get a, like, red or blue or something. I would prefer to have my PCB be lead-free, thank you. And we can get the engineers, once they've gotten their production file ready. So like they take our board files and then create their own files that describe more details about the production process, and we can tell them to like give us that so we can check first. Oh yeah, I can also tell them a specific place to put the order number on the PCB. And these are just various options for what to do around the edge of the PCB. Various, sort of more advanced options. As you can see, not too bad! When we get PCB assembly, we get the 24-hour build time for free. Let me see. It probably will be more expensive once I actually log in, because I'm not getting the, like, special pricing on it. Yeah, so if we look at their Gerber viewer, we need to sign in. I'll make an account later. Yes, this is relatively new where JLC supported this many inner layers on a PCB. We're certainly not gonna need 20 layers. But yeah, inner layers. So we have the like top and bottom. Inner layers give us more, well, just more layers to put stuff on. That makes routing easier, and it means you don't have to, interrupt your power and ground planes like we did. The red and yellow specifically, they really don't want us using the lead-free hazel. And white. Let's see, purple, blue, green, or black. I suppose we'll start with green. These are just testing boards in any case. But yeah, so that's kind of the process. This is a, I guess today's stream was kind of a like mini overview of the process of designing this stuff. Unintentionally, but this is sort of a expedited version, a much simpler version of what we're going to be doing for the whole design. As you might imagine, there's a lot more stuff that we're going to be putting on that PCB, and a lot more routing that we're going to need to make it happen. So yeah, I don't think I'll order them right now because I don't want the package. Well, you know, I probably could order them after stream tonight. But I don't know. I don't want the package to get to my house while I'm not there, you know? But yeah. As always, I hope everyone enjoyed the stream. I know I sure did. I'll probably be back on again before too long. Maybe more Sonic Rush? Yeah, of course, Pancake. And yeah, hope everyone has a lovely evening. I will be back soon with more video gaming. And eventually more of this, of course. Alright, see ya.